T-minus 10, 9, 8, 7, 6, 5, 3, 2, 1, 0, and liftoff of Space Shuttle Atlantis on a mission to build, resupply, and to do research on the International Space Station.
Houston now controlling. Atlantis begins its penultimate journey to shore up the International Space Station.
Roll, Atlantis.
Okay, Assalamualaikum, selamat petang semua. Terima kasih kerana sudi menghadiri sesi webinar kita pada kali ini, iaitu sesi Measure the Treasure Series. Yang pertama kali telah dibuat pada 3 minggu lepas mengenai drone in agriculture. Pada hari ini kita berterima kasih kerana kita ada satu lagi sesi Measure the Treasure Series bersama 3 pakar jemputan kita dan bersama moderator kita Dr. Hazariah di UniKL MIAT terutamanya. Kami terdapat ada beberapa research cluster. Yang pertama adalah Unmanned Aerial System, di mana sesi penerangan serba sedikit telah dibuat pada 3 minggu lepas. Sesi pada hari ini kita akan mulakan dengan Dr. Hazariah, di mana beliau adalah Principal Investigator di dalam Gas Turbine Research Cluster. Saya menjemput Dr. Hazariah untuk memulakan sesi kita pada hari ini. Jemput, Dok.
Okay, terima kasih Dr. Zul di atas ucapan alu-aluan. Thank you so much. So I'll take it from here, ya, Dr. Zul?
Ya, silakan Dr. Hazariah.
Alright, okay, see you again towards the end.
Okay,
Alright.
bye.
Alright, Assalamualaikum and a very good evening to all the audience out there. We are live today from 3 different platforms. The first one will be at the Facebook, UniKL MIAT Official. The second platform will be at the UniKL MIAT Alumni platform, Facebook, yeah, because we have our guests also an alumni from UniKL MIAT. And then we have another platform, which is the YouTube platform under the Women in Aviation MIAT. All right. So with me today, we have 3 panelists that are representing the industries, and also the academician. But before we start, since this is the first time Gas Turbine Engine doing the live webinar for the research cluster at UniKL MIAT, I would like to share a bit and information about the cluster. Yeah. All right. Okay. All right. I think everyone can see my slide in here. All right. Today we mark the first session for the Gas Turbine Engine Research Hub with the titles of the Gas Turbine Engine. Is it worth exploring? So we should wait what the panelists going to say about it. Yeah. I will introduce the panelists right after this. Okay, before that, before knowing the panelists, of course, you need to know your moderator. A bit about me. Used to be in an aircraft mechanics Malaysia Airline, working with the different types of aircraft, airframe and also power plant, yeah. And also, I'm proud to say that I'm an alumni UniKL MIAT back in 1998 when MIAT, formerly known as Mara Northrop Rice Institute. So I joined the MIAT since 2004. Been teaching the gas turbine engine Gen Fem and also the system of the gas turbine engine since then. But currently now, I just wanted to share that I'm also part of the consultant for the project under the space propulsion and also sustainable engineering. I start with the aviations, aerospace, and now part of the space program. So a bit about the cluster, yeah. We have cluster member, which is one of our panelists today, Cik Azhar. We have Cik Muzaffar, Cik Royhan. They are specialists working with the gas turbine engine, working with the industries. And we have a lecturer that works in the mechanicals department, in the aerospace department, Miss Putri and also Shakila. We have lots of different type of projects related to gas turbine engine and a few of consultant project, and we receive close to 200k grant as per today. Yep, a bit about the gas turbine engine. I know that most of the audience are very well known about the aviation industries. Might be some from the oil and gas, and also even some from the power plant turbine engine. Just a brief, we have different type of turbine engine, turbojet, turboprop, turbofan, and prop fan. So might be we can know more details from the panelists on what type of turbine they be using on their field. Yeah. So operation of gas turbine engine. So we have power generation, we have aviation turbine, and also we have oil and gas turbine. So by having that, let's not waste any more time. So we can, I will call up the panelists for today. Yeah? All right, let me stop sharing this one. Okay, so I will call the first panelist up to the stage. We have Mr. Azhar online, yeah? So we go one by one, yeah? So Mr. Azhar, how are you today? Apa
Fine,
khabar hari
thank
ini,
you.
Cik Azhar?
Baik, sihat,
Alhamdulillah.
doktor.
Yeah, thank you for accepting the invitation to be part of the live webinar today, yeah?
Yes, thank you. Yeah.
All right. Okay, Cik Azhar, I know that Cik Azhar been working with the industries for more than 26 years, but I think to know more details, a short brief about introduction of Cik Azhar. Might be Cik Azhar can share with the audience.
Okay, thank you, Dr. Hazaria, for giving the opportunity on this live stream. Okay, as you know, my name is Azhar Khalid. You can call me Azhar. Basically, I graduated in aeronautical engineering back in 1984. Right, that was way back. And then I started my career with Malaysia Airlines, airline system Berhad at that time, was in Subang. Yeah, as it's an engineer, technical civil. Since 1984, then I moved to Dubai, actually Emirates, to join Emirates Airline as a planning and a repair engineer. Yeah. Way back in 2010, I came back and I continued my career with UniKL Malaysia Airlines system, UniKL MIAT actually, sorry for that. Yeah, as a teaching staff or academician. Yeah, so basically my background was basically is in aviation all the way since graduation until now. But now it's a different world. It's teaching. Yeah, but we have a lot of experience way back with the industry. So I'll be make full use of it in the academic world. Yeah. So basically, that's it from me. So we hope to see you all continue with the session. Thank you, Dr. Azhar.
All right. Thank you, Mr. Azhar. So we know more details about what the background of the Mr. Azhar Khalid, yeah, the principal specialist of UniKL MIAT. So we move into a different background of our panelists for today, yeah. Our IRTS, Dr. Haris Abdul Rahman. So I welcome Dr. Haris on stage. All right. How are you, Dr. Haris?
Okay, I'm fine, thank you. So, thank you to Dr. Zira and Yat for inviting me to become one of the panelists. So let me use this opportunity to introduce a little bit about myself. Okay, I graduated from University of Technology in Malaysia way back in 2003. Okay, actually I started my career in automotive industries. Why? Because when I took my mechanical engineering, actually my major was in mechanical automotive. To be honest, I don't have any intention during that time to join oil and gas, but somehow after a few months of working with the automotive industry, I got an offer to join National Oil Company. So that's where I started my journey through the National Oil Company, which is Petronas. Okay, now it's actually today I'm already just celebrated my 70th year in Petronas earlier this month. Okay, during my 70-year journey, I actually have attached to 5 different business units. So I guess by exposing myself towards all these different units, actually it gives me a greater view in terms of how the business looks like, as well as involving in multiple types of gas turbine as well. Okay, I've been in downstream and upstream as well as with joint ventures. So far, hopefully during this session, I can share most of my experience with the crowd. Okay, I think that's all my introduction. Back to you.
Yeah, thank you, Dr. Haris, for that. But before that, I kind of like interesting in looking at the back your virtual background. Is that you back there?
Yes, that is during my younger days. Not
Yeah.
so young
So
lah.
what is that actually? Where are you during that time?
Okay, there was I think in somewhere in Malaysia, Thailand joint development area. There behind me actually was a gas turbine actually. It's an aeroderivative gas turbine, and it was meant to be installed at offshore platforms. Okay,
Okay.
so
Yeah.
something
So
similar like what you use for the for aviation industries, but this time
yeah.
around we utilize it for the oil and gas function.
Okay. So might be we can ask more detailed questions later on. Yeah. Thank you, Dr. Haris. Yeah. All right. Okay. Then we move to our third panelist. This is special to us, very close to our heart. Yeah, our alumni, Mr. Azrul Hafiz Azruddin. All right. He is the special process engineer at GE Aviation and also our alumni. Hi,
Hi.
Azrul. Apa khabar? How are you today?
Hi, Doctor. Hi, I'm good. I'm good. Thank you. Thank you for having me, Doctor.
Thank you for coming back to us.
It's a
All
pleasure,
right,
Doctor. It's a
Azrul.
pleasure.
Yes. Okay, Azrul. Might be you can tell us about a little bit about your background and what you're doing now.
All right. Yes. So as far as you guys know, I'm one of the product of the UniKL MIAT product, and I started my career in SME Aerospace in Sungai Buloh in manufacturing as a business development engineer. So over there, it was not so technical. It's more on the it's about 50-50 commercial and technical. And then I stayed there about close to 2 years, and then I move on to Aerospace Malaysia as one of the stress engineer. Okay, so over there we were trained for on the aircraft design. So when we're talking about aircraft design, it's not about how the aircraft should look. I mean, the not the cosmetic side of it. Is more on the on the stress limit, the fatigue design, the composite design, right? So that's Strand Aerospace Malaysia. And then during that time, I was sent to one of our client as a technical services engineer in Eagle Express Air, where our base is in KL and Jeddah, Saudi Arabia. So we do charter airline for our Umrah and Haji Jemaah lah, right? And then now currently I'm in GE Aviation as a special process engineer, covering cleaning and inspection. So that's
All right, Azrul. If I may ask you, you are
yes.
graduated in what year? Yeah, and in which program?
So, sorry, Doctor?
Yeah, you are graduated in what year
Okay.
and which program?
I graduated in 2011. So it's
Uh,
been 10 years from 10 years from now. Yeah,
yeah.
it's
Is
already
it
been
degree
10
in
years.
mechanical?
Yes, in Bachelor Aircraft Engineering Technology.
Okay,
Mechanical,
all
yeah.
right. Okay, good to have you back, and good to see you again. All right,
Thank you,
Azrul,
madam.
thank you so much. Okay, all right, so we move into our first panelist, yeah, Encik Azhar. Encik Azhar, we have been knowing you for such a long time, yeah,
Okay.
and
Yeah.
we know that you are our specialist, and we always refer to you. And I know that all the engines that we have in UniKL MIAT need to be reported to you on the process, on the maintenance and kind of thing, yeah, you and your
Yeah.
team. So I would like to ask you about your work related to gas turbine engine, and also might be detailing on the UniKL MIAT.
Yeah. Okay. All right. Okay. Thank you, Dr. Azaria. Okay. So basically, UniKL MIAT, which I joined in here. Doctor, is the slide on? Excuse me, Doctor.
Yes, Chaza, the slide is there.
Yeah, but it's not scrolling. Yeah. Not scrolling.
Yeah, you can control it from your side.
Okay. Yeah. You see that? You can see now? Yes.
Yeah, we can see the slide. Can you
Okay.
control it from there? Okay.
Yeah, yeah, okay. All
Okay,
right.
perfect. All right.
Okay. Sorry, guys. Sorry for that. Okay, so this is UniKL. I joined in 2011 March. It's a challenging university. It's a technical university. So we actually basically is technical university where we maintain the aircraft. Yeah, aircraft provide courses for the aircraft. This is what we are. We have all the airplanes down here, and the students are in blue uniform. Yeah, and the instructor. In 1997, we have the MNRI, Mara North Stock Rise, that was formed in 1997. And then we also have the training approval, which is basically is a ATO 147 approved training organization, where we have approval from the Civil Aviation Authority of Malaysia and also from European from EASA, European Aviation Safety Agency. Yeah. Our vision, basically, UniKL vision is to become the leading entrepreneurial technical university. Yeah. So we have 12 campuses, which you can see from this slide now. It's all over Peninsular Malaysia. It's too bad it's not in the East Malaysia. Comprising of all those from city campus, KL campus, and those are the profession. Yeah. For example, the trade they are on. Similarly, with other campus, Bangi campus, we have Gombak, UniKL British Malaysian, it's all over there. And basically, I'm trying to show here where we are here, Sepang campus. Yeah, this is where in Kuala Lumpur, Malaysian Institute of Aviation Technology is. Yeah, we have two campus actually one campus, but it's extension. Yeah, we started at Sepang campus, and then in 2014, if not mistaken, we have the Subang campus extended. Yeah, okay. So this is a historical view, which you mentioned on the earlier slide, from the way back 1997, and it was IKM. We joined Jasin, and then we have at that time in 1997 we only offer certificate program. Yeah. And then in 2001, we were on our own, and we call it Malaysian Institute of Aviation Technology program. Yeah. Then Mara and the government have started to group up us to be a university, and in 2002, 2003 actually here, where we were part of University Kuala Lumpur. Yeah. Right. The same one to show you the progress. earlier on that slide. Basically, this is our campus Sepang. The front, the admin block, you can see from the aerial view. And over here, it's the new Subang campus, not new anymore. I think it's already, what, 4 years, 5 years. We have the admin block and also the hangar. Yeah, these are the hangar facility. Okay, the only difference that we have here, we have the apron and we have the hangar here. We do not have any live aircraft that can possibly be operated in here or maintained. Whereas in the Subang campus, which is here, you have the live So those are the difference, and we were pushing for this to have the live aircraft, so that, and we have the live aircraft, the Hammock and also the Galaxy helicopters were operating these facilities. Right, this is the aerial view, Sepang, yeah, on the other aspect. Similarly with Subang, okay. And this is the overall view, yeah, which is in Subang. Right, the facilities we have here, the one in Subang, we have the admin block, academic block, classroom, faculty member for training workshop, the hangar support, hangar 1 and hangar 2. Yeah, these 2 hangars are the ones that we can park 1 narrow body aircraft and 1 wide body aircraft, a Boeing 747 or 777. Yeah, it's possible to go in there to have it. Basically, airside area, yeah, it's controlled. So that's where the security is. And over here, it's your Sepang campus, the main campus actually. You can see these are the hangar building, and behind it, that is your classes and the blocks, yeah, and the workshops, yeah. Right. Okay, here is the earlier the Sepang campus area view. Similarly, Subang campus. This was way back. This picture was taken way back. Maybe before we started, when we had this only at that time was tapak cadangan. And we just started to set up the Subang campus. Yeah, way back at history. Similarly, on this one, Subang campus location, which the yellow part, and this is supposed to be the taxiway. Yeah. For the aircraft to taxi in and out, yeah. Connecting the industry. So over here, you will have this for the over here. You will have the live aircraft, yeah, that will be parked into the hangar for the right maintenance, yeah. So, and we are in the center of this aerospace hub here in Subang. So this very strategic position, yeah, for it to go, yeah. Right, this was the earlier one, Lantapak, way back before it was set up. Okay, the technical programs that we have basically is the CAAM, Civil Aviation Authority of Malaysia, yeah. So we are approved 147, which is basically a maintenance training organization. We are capable, we are authorized to conduct courses for this trade: aeroplane turbine, aeroplane piston, helicopter turbines, helicopter piston, and also avionics. These are all for maintenance engineers. Yeah, so that is the approval from Civil Aviation. Similarly, we also have EASA approval, yeah, which tells you to accept we do not have 1.4 helicopter piston. Yeah, and these are current, and we are conducting courses both of these programs. Yeah. Okay. Apart from that, at MIAT, yeah, being industry background in aviation, yeah. So I have the opportunity to conduct classes. Yeah, we're given classes, gas turbine classes for both the diploma and degree programs in bachelor in aircraft engineering technology and also for diploma programs. Yeah. So these are the workshops. This is in Subang actually, where it's a turbofan Garrett TFE 731. This is static, and we can disassemble electrical engine, which is operable. So you can do the full engine run, and not actually full, up to idle power, yeah, to see the operation of the engine. Yeah. So this is the mini lab, which is also stationed at Subang campus. It's a micro turbine, really. It's by turbine technologies, where we use this for our lesson in thermodynamics. Yeah, it helps in understand the thrust, yeah, the thrust, and also the flow of the air through the turbine and so on. So this is one of the equipment that we use to teach the students. Yeah, so students have the opportunity to actually understand, yeah, understand and learn from the equipment that we have. Yeah, and this is another equipment which is a turboprop, 56 turboprop. Turbo propeller, which is also operable. Yeah, we can run 250. It's a turbo shaft engine. Yeah, so turbo shaft is a turboprop. So turbo shaft is for the helicopter operation. So basically, these equipments are maintained in Subang and also in Sepang. We have similar of this in Sepang, and besides our lectures, yeah, our theoretical lectures in the classroom, students have the opportunity to actually to work on this engine hands-on. Yeah, so that is the advantage having this equipment, having this, you know, in the university, where students will now actually, though it's not the latest technology of gas turbine, but the fundamentals are the same. Yeah. Okay. All right. Okay. From there on, yes, doctor.
Oh, yeah. Oh, okay. Cik Azhar, I think we being able to capture all the latest engine that we have in UniKL MIAT. As you were saying
Yes.
that it is can be can be run, and the students can monitor the engine running, the engine run procedure too. Yeah.
Correct. Yeah. So they can actually simulate, simulate like the real world situation. For example, here is a micro turbine. Yeah, but the process of starting is the same. Similarly with this turboprop. Yeah. So you have all the equipment, you have the system, you have the fuel system, you also have the control panel where actually it's the system have the feel, yeah? The student will have the feel that they be able to run, and what are the parameters that they should be alert, yeah, when they actually observe and during that engine run. Yeah, turbo shaft, yeah, we also have an engine similar. So those are the things which the student would feel that yes, I'm in a situation where what I learn in class, what I learn about thermal efficiency, what I learn about overall efficiency, the Brayton cycles, the theory behind it, yeah, they actually can relate it when you actually do the engine run. What parameters are, why they are so important in terms of your compression ratio, in terms of the thermal, in terms of the hardware, yeah. So there are limitations where they can relate to the theory that was taught in the classroom. All right. So
Okay.
sorry, yeah.
Yeah. Oh, okay, Cik Azhar. We will have another further question right after this, yeah? Okay,
Okay.
I will. All right. Okay, thank you, Cik Azhar. Yeah? So we will see you again in the next round.
Thank you,
Okay,
doctor.
then, okay. So we have Dr. Haris here. So, Dr. Haris, I know that we at MIAT are talking about the gas turbine engine aeroderivative being used for the aviations. Okay, so this is very interesting, and we already have lots of comments, and we have close to 100 over participants that watching us now. Yeah. So, Dr. Haris, you are from the oil and gas industries, from the big companies in Malaysia. So, it will be so honored to have you. And perhaps you can share with us the what did you do, and detailing on the gas turbine engine being used at the Petronas. Over to you, Dr.
Okay.
Haris.
Okay, Dr. Azria, can you show my screen?
Yes, it's already on screen now.
On? Okay. Can you hear me? Hello.
Yeah, we can hear you, but just now it's a bit lagging, but now it's okay.
Is that now?
Over to you.
Okay. All right. Somehow I couldn't hear. Okay, the sound. Right. So I hope the participant can hear what I'm trying to deliver today. All right. So the sharing today is more on to cover on what gas turbine is. Right. I think we covered this, but this is just to show what I'm doing currently right now. So actually, when I started my journey looking at the physical form of the gas turbine itself, but now what I'm doing is more to digitalize things. I can monitor all the gas turbine all from my office. I don't need to go to the site. Okay, as long as there's a sensor connected to all the machineries. Okay, I can use that, take all the data from the sensors and start to monitor all those machineries. Not even from the office, I can also do it from my home. Okay, let's talk a little bit about the commercial utilization of the gas turbine itself. Okay, I'm not sure whether you guys are aware. Okay, on top of the most popular, of course, is the gas turbine is being utilized in the aviation industries. It's being used for the Airbus, A380, the Boeing, all those aeroplanes. Okay. On top of that, some of the super helicopter also utilize gas turbines in order uh, as their engines. And definitely in my industries, in oil and gas, we use gas turbine in order to be utilized as power generation, as well as to drive equipment such as compressors, as well as pumps. So in certain cases, there are also heavy tanks which being used in Iraq war, for example. They also, the tanks is quite heavy, right? But so they need a big engine, a big and powerful engine in order to make sure that the tanks can be drive very fast. That's why actually the tank is being driven by gas turbines. So on top of that, we also utilize gas turbine in power as well as utilities plant. And last but not least, there are also applications in the maritime where the ships are actually being powered using gas turbine. Okay, let me touch a little bit about my own industries. Okay, this information is actually readily available in Petronas website. But what I'm trying to explore here is to explain in terms of major businesses that we have. We can start with business number one, which is upstream businesses. This is where I am right now. So you can see from this high level overview, there are large numbers of offshore platforms, so almost close to 400 offshore platforms. But what we can focus here is actually the number of rotating equipment as listed in the list. We have approximately about 83 numbers of compression equipment, as well as 281 power generators. So majority of these two main equipments are actually consist of gas turbines. So you can imagine the numbers that we have covered in oil and gas in Malaysia alone is quite a lot. Those are the platform that utilize gas turbine as part of our power generation as well as compression equipment. So next we can focus on business number two, which is gas and new energy. In a nutshell, we have a few LNG assets here. We have the LNG plants as well as two numbers of floating LNGs. So in those plants as well as the FLNGs, there are also numbers of major rotating equipment, which also includes gas turbine. On top of that, we have a few gas plant and power plant. So in order to transmit gas from one place to another, of course, they need to compress to make sure that the compression the gas is being compressed to have the enough energy to be transferred from A to B, for example. So that is where they need to install a big size compressors, and usually the driver will be a gas turbine driven compressors. And next we also have downstream. In downstream, we have business that we call as refinery, as well as petrochemical. This is where sometimes we also utilize gas turbine at these locations. On top of that, actually, we also have our own lubrication division, where actually I think I have a detailed slide on that. In order to support the gas turbine industries, we also have our own lubrication oil, which is meant to be utilized for gas turbine. Okay. These are actually the typical gas turbine application for oil and gas. I can divide into two. One will be the gas turbine compressors on the left, as well as on the right will be gas turbine generators. The main differences will be on the driven equipment. Okay, the driver will always be more or less the same equipment, which is the gas turbine, but either the gas turbine will be driving a mechanical equipment, it's either compressors or pumps, or it can also drive a generator where the generator will generate power and the power will be distributed to the designated locations. So in order to support this gas turbine, of course, you need all the auxiliaries, okay, which without the auxiliaries, of course, the gas turbine cannot be operated in the designated locations. So I think that will be the major differences between oil and gas application versus aviation, where usually in aviation you can see the big large engines and beneath it, of course, you have all the hydraulic system. But for oil and gas application, usually you just see a big box, the enclosure itself. You rarely see the gas turbine itself because the gas turbine is actually located inside the enclosures. But most of the time, you can only see all the auxiliary system, okay, which is meant to support the gas turbine operation itself. Okay, this is a thing that I touched earlier. Actually, I'm not sure whether the crowd is aware or not. Petronas also produce our own lubrication oil for gas turbine engine. And the oil brand is being called as Petronas Gentram. More or less, we have two major grades. One is synthetic lube oil, which is to be utilized for aeroderivative engine. And another one will be normal Gentram, which is mineral based. Okay. It's much cheaper compared to synthetic and is meant for industrial gas turbine application. So hopefully, the Malaysian industry can also support by buying Petronas product. Okay, I'm trying to promote a little bit on Petronas product here. Okay. Right. Let me touch a little bit about the current latest trend in industry demands. Okay. First of all, as what I mentioned earlier, the one that I really involved with right now is more on the digitalization, where people start to look into how to remotely monitor your equipment. So this is where I am right now. Okay. I'm currently based in Petronas Twin Towers, and my team is currently being given the responsibility to monitor up to 200 plus numbers of major rotating equipment, which also includes gas turbine. So we also, our main task is also to monitor gas turbine, which not only located in Malaysia. Okay, we also have few units which also located in our international asset. So it's quite interesting, right? I think there will be large demand on this. So this is where the niche area will be that people will be able to focus with. Dan trend number two, maybe I will touch a little bit about emissions. Okay, I think the buzzword that people would like to use right now is always about going green. Okay, even we have to admit that if we use gas turbine can also become one of the major contributor in terms of NOx as well as CO2 as well as the overall emissions. Okay. But this is where we always collaborate together with our technology provider. Okay. For example, we have multiple OEMs. The major OEMs that I always deal with, for example, Siemens, Solar Turbines, as well as General Electrics. We always communicate and discuss with them how to make sure that the gas turbine that we have right now, okay, to control the combustion as well as the emissions, to make sure that the emission that is being emitted daily by the gas turbine actually can meet the requirement that has been set by DOE. DOE stands for Department of Emission. Last one that I want to touch is more on the efficiency. The more efficient the gas turbine is, okay, the more that we can save in terms of fuel, because the higher the fuel that you burn, actually, it means it's being translated to higher costs for your company. So as an engineer or technologist or technician who involved or wants to contribute to your company, of course, you have to look into the overall efficiency of your whole system. You don't want to run your gas turbine with low efficiency, because in the end of the day, it means that your company has to fork out additional money in order to maintain or to run your machines. So how to monitor, how to increase the efficiency of your machines? This is where the engineering, the studies, or you can collaborate with the experts on how to increase the overall efficiencies. Okay. So let me touch a little bit, okay, based on on the career opportunities which relates to gas turbine. So first, you can always choose what are the type of industry you want to involve with. It can be either in oil and gas, it can be power utilities, it can be aviation, marine, okay, even armored force, okay. For those who join the army, especially actually the gas turbine is also covered more or less in two. One is TUDM, Tentera Udara, okay. The other one will be of course the Navy. I believe uh, both covers gas turbine requirement in terms of the engineering part. You can also join a team which perform research and development, which also relates to gas turbine. MRO stands for forgot the full name. It's on the overhaul, okay, how to repair, maintenance, repair and overhaul facilities. I think this is actually applicable not only on aviation, but also applicable in oil and gas. And you can also join the suppliers, because there's a lot of suppliers or subcontractors who actually become the major support of all this equipment. Remember earlier when I touched about the auxiliary system, okay, the auxiliaries, without the auxiliaries, okay, like hydraulics, loop oil system, so on, without those small suppliers, actually the gas turbine cannot be run by its own. It still needs the supplies or the improvement that needs to be done by all these suppliers. Next, you can also check which sites you are on. Either you can join on the end users, or the operators, okay, or the owner of the asset. You can also choose to join maybe the OEM themselves, who has all the technical know-hows in terms of how the machine operates. You can also join the suppliers or even a third-party service provider, because there are some cases, where, especially overseas, where after working with the OEM for several years, they already gain all the knowledge, all the confidence, and they are brave enough to come out with their own third party, to become a third-party suppliers in order to reduce the overall maintenance costs. So it's like owning a car, right? Let's say, for example, you own a Honda. It's either you send your car for repair to Honda, or you can also send to a third-party mechanics. Okay, this is more or less a similar analogy that I would like to use for the third-party service provider. Next one, actually, if you want to design something or come up with some improvement, the thing that I mentioned earlier, or even you come up with ideas on digitalization, you can also become a design consultant, or people need to be trained, okay, need to get their knowledge. You can also join as a training provider, or in fact, you can also become a lecturer, okay, by joining the education sector. So on the right side, those are the sample, okay, of job opportunities when it comes to gas turbine. Okay, you can also become an operation engineer. You can join the maintenance part. Okay, it's not necessary for you to be graduated and under mechanical discipline, right? You can also come from different background, for example, electrical, instrument, or in fact even chemical, because when it comes to gas turbine, it's actually multidisciplinary. You need these people in order to contribute towards proper operationalization of the gas turbine itself. Okay. On top of that, we also have reliability engineer, we have project engineer. In order to conduct or install new equipment, we need the project people to do it. So we also need sales people who love to do to sell items, okay, to do some marketing, things like that. So without the sales people, of course, people would not be able to know or how to sell a gas turbine. And in fact, control system engineer, usually this comes on the background of electrical or instruments. So those are the sample of career opportunity which relates to the gas turbine itself. Next one, okay, we can also have installation engineer, construction, KLKC. In fact, we can also have specialists on materials, because when it comes to efficiency, of course, it's all about the combustion part. If the turbine can generate higher temperature, okay, it means more energy that can be generated on the combustor side. It means they can generate more power, and of course, it might be translated to higher efficiency, right? So we also need material expert in order to explore in terms of the R&D, as well as coming out with new advanced material, so that or even advanced coating, which can prolong the blade itself, and even contributes towards a prolonged overhaul period for the machine itself. Okay, nowadays we talk about digitalization. Of course, I think you can also opt to become a data analyst or even data scientist to understand what is the machine behavior. You can study about the validity of big data is there. It's just a matter of we need specialists or people who understand the science behind the data and come up with the prediction when the machine is going to fail, okay, to predict failure or to prevent the failure from happening. So those are the niche area that we are looking for right now. Okay, last but not least, okay, if you want to stay in office, you can become the entrepreneur itself, to become managers, okay, to work as a design consultant, as lecturer, as well as trainers. But bear in mind, I'm not saying that they will always stay in office for most of their work. Okay, they also need to go to the site, okay, to see what's happening in terms of the how the gas turbine look like, and as well as joining the people who's at the field. I guess that's all covers on my slide. So I think I can pass over back to you, Dr. Hazaria.
Yeah, that was an interesting information that you were telling me. Also learning a new things, and I think the audience out there also have some questions already being coming out through the platform. Yeah, and to the audience out there, if you have any questions, we will try to accommodate it, and please post it online. And Dr. Harris, related to your presentation, there's somebody from the online was saying that wow, there's an amazing. They can see your picture on the AR turbine engine. Can you move to the slide where there is a latest trend in the end industry demand? Yes, exactly. They was
This one.
asking me, is that your new project with the Petronas that you were mentioning about the monitoring about 200 plus the rotating equipments? Is it the, I think if I'm not mistaken, is it Protium?
Yes. Okay. All right.
Yeah.
Actually, this is more on marketing side. Okay, I have to admit that this picture looks a little bit futuristic, but at least we have a dream. This is where we want to go, right? We talk about AR or virtual reality. Okay, our aim is to have something similar to this. We need to go to site. If we can have some kind of 3D model which can be shown in front of all the team, so actually we can pinpoint where are the problems and tackle it here and there. We don't need to go to the site, but that will be the dream. What we have right now, is the actual one is only this, all the big screens that we shown here. You can only see the data, but not up to the 3D model yet. But by showing that, actually, is first of all, of course, I need to attract people, right? Those are more or less the marketing that we have. Okay, but there are plans to move toward that in near future. So, because people are
Oh,
talking about the virtual reality, you wear all the gadget or device, you can see the virtual or digital, call it digital twin of your equipment in front of you without needing to go to the site.
yes. All right. Thank you so much for the explanations and the presentation. We'll see you in the next round. Yeah, Dr. Harris. All right. Okay. We've been talking about the academic point of view. We've been talking about the industry point of view of the gas turbine engine that being used in the oil and gas. So now we have our next panelist, Azrul. Yes, you are working with the GE Aviation, yeah? So, yep, perhaps you can tell us and the audience out there that watching today, what did you do in the industries at GE company? Yeah, over to you. You're muted, my dear. All
Okay,
right.
thank you, Dr. I do in GE Aviation. First, I think we need to understand what do GE Aviation do lah. All right. So we can start with so basically GE Aviation. So there's two part of GE Aviation lah. Mainly there's two part. One is the new make where they manufacture the new engine, and another one is on the MRO side. So where we do servicing and overhaul for the engine lah. Okay, and then I am on the MRO side of it. So our plant is our engine shop is located in Subang, Subang Airport, just behind the old MAS complex. So we are still there. Okay. Okay. So when what we do is so we overhaul the engine, all right, and then I would like to say when engine that comes into our shop, there's two types of engine. One is I would call it a healthy engine, the one that come for scheduled maintenance, like when you send your car for scheduled maintenance, right? And another one, what we call the hospital engine. So that is where the engine come with a problem like a bird strike or vibration or in-flight shutdown and so forth, right? So the one that I'm going to walk you guys through is so this is the I would say the normal overhaul for the healthy engine. All right. So what we do first is the induction. All right. As you can see, the induction is where we I would say we plan what on the work scope of the engine. So work scope is basically what are we going to do with the engine. So it's like you sending your, like Dr. Haris mentioned, like your Honda car, kan? So when you send your Honda car to the Honda service center, right? So when you at the counter you say I want to send my car for minor service or major service, right? So if you say you want to go for minor service, then they will tell you, okay, minor service, we will change the oil, maybe the oil filter, all right, and so forth. So that is the work scope. That is the work scope for minor service, all right? And then we have more scope for major service as well. So for engine, we have work scope for healthy engine that's coming, the scheduled maintenance. One of it we have is LLP replacement. So LLP replacement is life limited part replacement, because some of the critical parts on the engine are life limited. So life limited is like so you cannot like forever use the part. Okay, so it's just like your car timing belt. All right, so for every 100,000 kilometers, you have to change your car timing belt. Otherwise, if you go more beyond than that, there's a risk of the timing belt will broke, right? Okay, and then same goes with the aircraft engine, with the gas turbine engine, right? So there are few life limited parts, right? Most of it are rotating parts, like the rotor, the disc, right? The spool, the shaft. So that is where the engine comes in for the LLP replacement, or basically what we call a major overhaul. All right. For those who wondering how frequent engine have to come in for the full overhaul, it's usually before 20,000 flight cycle. All right. In layman term, flight cycle is basically when you on your engine and you turn off your engine. That is what called one flight cycle. Right. So you turn on engine and turn off, that is one flight cycle. So before you hit 20,000 flight cycle, you have to send your engine for a full overhaul or LLP replacement. That will take you about I think around 6 years. Usually it's around 5 to 6 years. Then you have to send your engine, your gas turbine engine, for a full overhaul. All right. So when the engine comes in for induction, we will plan what to do. That's the work scope. So this is where we look which part that needs replacement. And for those who are familiar, the AD, the Airworthiness Directive, and the service bulletin, which AD and SB that we have to implement on this engine. So we do all the work scope here, and then we propose the work scope to customer. And then there will be some back and forth communication to get on the same page on the work scope lah. All right. So after that, once we get the work scope, we get all the paperwork sorted out. Then the engine comes in for the disassembly. All right. So disassembly, the first stage here is we do from the engine level. All right. From the one piece, one big engine, we disassemble to a several module. So FYI, we have 4 major module on our gas turbine engine. All right. Okay, so for this one, the example that you can see here in our the background picture here is the LEAP, if I'm not mistaken, the LEAP 1A engine for Airbus, the Airbus A320 Neo, the new Airbus. Okay, so this for LEAP 1A. So this assembly from engine we separate into 4 module. The first module is what we call the fan and booster. All right, the front part of it. Okay, you can see the fan here and the casing there. All right, and then the second module is the core major module. The core is basically the I would say the hot section lah, is where your high pressure and high temperature area. All right, and then we have the turbine. The third module is your turbine section. That is the third module, and the fourth module is the accessory or the gearbox module. So for those who are not familiar, our gas turbine engine for aircraft gas turbine engine, the gearbox, we have about 3 gearbox, right? It sit beside on the fan case. You can see behind this at the background picture here. You can see some. These are some of the gearbox here, right? So after you disassemble into 4 major module, right? This module, then we further disassemble into the piece part, all right? All right, so because full overhaul, you want to do piece part, you want to take out everything, right? Until for each, you have to count for each bolt and nuts lah, right? So you disassemble until the piece part level, and then the next step is cleaning. All right, this is where I come in lah. So cleaning, we do piece part cleaning for all the parts. Okay, so some cleaning are very straightforward, like hand wipe cleaning. Some cleaning we just use some alcohol or acetone, just hand wipe. And some part needs a much more complicated cleaning process, where we have to take the part and put it on inside a chemical tank, right? This chemical tank, I tell you, is no joke. It's quite a high concentration and high temperature. So it can remove like coking. Coking is, for those who are not familiar, coking is where your oil inside that attached on the part, and then it gets subjected to high temperature and heat, like frequently. So in time, the oil become hardened like solid rock. So that is what we call coking. So sometimes you have those coking on the part, so we have to clean up. So normal cleaning method cannot clean this coking, so we have to use quite a heavy cleaning method lah. All right. Okay, and then after you clean the part, then we push the part for inspection. This one, the inspection including the NDT, non-destructive testing, for those who are familiar. And then we have the visual inspection. Visual inspection is pretty straightforward. Like we visually inspect with our eyes or maybe with some magnifying glass. And then the last portion one is the dimensional inspection. So where we take measurement, right? Because sometimes you might end up with part that cosmetically, physically looking that looks good, but sometimes the dimension is out, so you cannot assemble the part back onto its engine. All right, so NDT, visual inspection, and dimensional inspection. So after we finish up with the inspection, so this is where the inspector will make a call whether for each part, whether those part is it serviceable, repairable, or scrap. All right, so this is where we make the call in inspection. So this is also where I support, so both the cleaning and inspection. All right, so this is kind of a hot seat because this is where we decide this $1,000 or $100 or $1,000 part, whether it's serviceable or repairable. So it's kind of a hot seat to stay in that position, but it's very interesting. Okay, so after that, so let's say the part we decided that the part is serviceable, then the part we will straight to the warehouse for accumulation. If the part needs, we need repair. If the part needs repair, then we send the part for repair. Okay, if scrap, then we straight with scrap. All right, so the next process there is the repair. So some repair we do in-house repair where we the part we retain the part inside our own shop and we do the repair on ourselves. But much more complicated repair that we have to send out the part to other shop as well. All right, and FYI, some of the some of the repair, I would say like a proprietary repair. Proprietary repair is like normally is a high-tech repair that even GE doesn't share with us. We have to buy the license just to have a look on the document of the repair. So that one usually is a high-tech repair lah. Okay, so that one we have to send the part out lah. Sometimes we send back the part to UK, to US, back to the States. It depends on where the shop located. All right. So after all that, okay, usually around 7 days prior to the assembly, we count all the parts is there in the accumulation process, and then we decide on the configuration. All right. So because if you know, like for example, if you for example this engine LEAP 1A, even though it's LEAP 1A is the model, and then we have like several variant of a LEAP 1A. So that is what we call a configuration. So each configuration it have its own combination of part numbers. So they have to make sure that the configuration is correct. Right. So because there has been an incident where they mess up the part number combination, so they mess up the configuration. So we have to recall back the engine and rectify those lah. Right. So okay, and then after all that, so we start to do the assembly process where we assemble the piece part to become module and move on to the this one where we assemble the module installed back to the engine. Right. After all that, the next one is the testing. So we send the engine for to our test cell. So we have our test cell. So this one, so I think we as a Malaysian we have the right to do some flexing here or brag, because we are the one that in the whole world in the GE shop we are the only one that have the LEAP 1A LEAP engine capability with the test cell on site. Some GE shop, some shop around the globe, they have the capability to service the LEAP engine, but they do not have the test cell on site lah. So what we have those lah. So that is it's like our crown jewel lah, right? So that is our selling point. So customer, if they want to send the engine to our shop, so we can do the overhaul over there, and then we can do the testing over there, so all under one roof. Okay, and then after the testing, so after the setting, the biggest, the most important part is the ARC. ARC, for those who didn't know, ARC is basically the certification process. So ARC is the certification to say that this engine is safe to fly, right? This engine is safe to operate. So that is the most important one lah. Okay, so moving on, let's go back to the cleaning inspection. So where I involved in G Aviation. All right, so in cleaning, so I provide like technical solution regarding cleaning process. So we do have sometimes some what we call insufficient cleaning. All right, so the manual, most of the aviation guys know, even the student know, that we have to do everything as per the manual, right? According to the manual. But manual is not perfect. Okay, so the manual is written by human as well. So sometimes the manual not perfect. There are some flaw, and sometimes when they write the manual, they do not foresee what's going to happen for on that engine during operation, right? So sometimes we end up with part condition that are not foreseen, all right? That were not foreseen. Okay, so that's why sometimes we end up with insufficient cleaning, all right? The cleaning method provided by the manual is not sufficient to clean those parts. So that is where I came in to come up to basically just to tell them how to clean the part, all right, in layman term. But being this is being a special process, this is there's several parameters you have to watch out. All right, the material of the part, what chemical you want to use on the part. All right, so I can share with you one of my mistake when I was during my first year as the special process engineer. We accidentally put the part on the wrong chemical on the titanium parts, and we dunk inside the chemical tank. When we retrieve the part turned out to be blue. So all of us were panicked. So so when we investigate this, basically there's one step we missed before we went for the chemical tank. We used the correct chemical, but there's one step we missed before we go for the chemical tank. So special process, you have to be very, very careful, because special process is a thing that when you did something on the part, the only way to find out whether it's okay or not is to do destructive testing. You have to destroy the part, right? So that's why special process is that you are required to have some good background or knowledge in science, material science, whatsoever. Okay, so whenever I came in to suggest what chemical to be used, what cleaning process to be used on that part, so I have to take account the material, what material of the part is, what chemical, and then sometimes I leverage from the manual itself. All right, even though the manual is not complete, but we can leverage from what they have inside the manual. All right, and then we do some process control. So I have to make sure that all the chemical tank are in the acceptable range of concentration. All right, the chemical cannot be like too concentrate or cannot be too dilute. All right, so we have to take care of the concentration level and the water as well. The water used inside the chemical tank is not the normal water. What we use is what we call the deionized water. All right, so deionized water is quite special. Because it prevents your part from being what we call oxidized. Okay, normal water tends to do that. If you are like some normal water tends to leave a watermark. For example, you can take your car, for example, when you send your car for a car wash, right? So you can wash your car every day, but sometimes the watermark you cannot take off the watermark. You cannot remove the watermark from your car. That is caused by our normal water, our normal tap water, right? Because there's a quite high number of ion inside the water. I mean, it's not harmful to our body, but cosmetic wise, it's not looking good lah, and then it can cause corrosion. All right, and then that's why we use deionized water. All right, deionized water is the ion inside the water is very, very less. It's very less, and then the resistance, the water is quite resistant. As what we know about water is very conductive, right? That's what we all know. But deionized water is very resistant, so it cannot conduct electricity. So that's why it cannot oxidize the part as well. So your part cannot be corroded, right? So that's how we take care of our engine parts lah. All right, so that's process control. And then moving on to inspection. Okay, so inspection is where we do the NDT and the visual inspection and dimensional inspection, like I mentioned before. So that's why I have to, if you can see why I have to take care both of the process cleaning and inspection, because these two are very related. Because if your cleaning is not good enough, if your part is not clean enough, it will be difficult for the inspector to inspect, right? There might be some defect. Some defect underneath, lying beneath the all the dirt, the grease, the oxide, right? So the cleaning is very important. So and then that's why the part have to be like memang baru punya, like very clean. So it will help the inspector to make an accurate technical disposition lah. All right. So my function here in inspection is to provide some as a technical advisor to the inspector. So we have a few inspectors working there. All right, because so my as an advisor, so sometimes they have problems interpreting the manual. That's the easiest one. Sometimes they have problem interpreting the manual, interpreting the manual limits, the requirement. So I will be there to explain to them what the manual is talking about lah. And then sometimes to help them to make disposition lah. I mean, this defect on this part is serviceable, or whether it's repairable or serviceable. Okay, this is usually happen on the new inspector lah, which is and I'm encouraging the new inspector to raise their hand, right? Because that is how we learn, right? If they keep silence, it's the learning process is not good, right? It will take longer time to learn. So I am encouraging my new inspector to raise their hand every time they are not sure lah. All right. And then the second part is I support this. I provide disposition via through DICA. So DICA, for deviation and departure. DICA is one of the document that sometimes you have incidents like when you found a defect, the defect is not covered inside the manual. That is what we call the manual silent defect. all right? And then sometimes we have a beyond manual limit defect. For example, your manual allow you to have a crack around 3 millimeters, but then the inspector found out the crack is 5 millimeters. All right, I mean you can, I mean technically the part is not serviceable, right? You can straight away scrap the part because it's already above the limit. But I mean we as part of our like cost initiative, right? We try to save costs for our customers as well, right? So we try to seek OEM approval, right? And we send them the damage report, and then we propose to them how to repair the defect as well. And then if the OEM approve our request, so they will provide us with the document what we call a DICA. So DICA is deviation to instruction for continuing airworthiness. It sounds fancy lah, but it's actually pretty straightforward. So basically, when you get the DICA, you can perform those repair on the part, even though the part is not serviceable according to the manual. But it's a case-to-case basis, right? This one is quite critical and very interesting one. Okay, so this is where you have to apply some technical knowledge, when you want to make disposition. All right, you have to identify what type of defect, I mean how the defect occur, and what are the chances to get the defect repair, right? Because your technical thing is one thing, and you have your workload as well, so you have to balance that out. So to do that, so if it's good if you have a good technical background or technical knowledge for you to make that quick decision. All right, sometimes when you see the part with the defect, you know it's not worth it. It's not worth your time to go through all the hassle to salvage your part. All right, so you just straight away scrap the part, right? So all those experience and technical knowledge will surely help you to make all those quick decisions. And then the next one is inspection process development and improvement. So because the manual only tell you what to inspect, all right, they for on the inspection side, but it's us that have to come up with our own inspection process, right? So what machine to use, all right, and plus some more now we're going to the IR 4.0, the Industrial Revelation 4.0. We are trying to digitalize most of the equipment, all right. Some of the equipment we already digitalize those equipment. For example, the depth, how to measure depth. Before this, all right, before this, we use the normal depth and gauge. Now we have like 4D tool where we can scan the surface, and there's a 3D surface pop up on the screen, so you can measure straight away, measure your depth. All right, and the last one, some bonus function. My role in GE as a Kaizen start point. All right, so Kaizen, some of you guys might know. So Kaizen is a lean thing lah. So I encourage for those for the student to Google up what is Kaizen lah, because Kaizen is the thing in the industry. All right. Yes. So that's all for me. So that's my background lah. So what I do in GE Aviation. Thank you.
Okay, actually, I'm smiling all the way back from the stage because we received a few questions related to your field, and I think that I have to come out to the stage and say, okay, you might want to ramp up a bit. Okay, all right. As we will keep the questions towards the end of the session. Basically, if following the schedule, we have only 1.5 hours. But I think listening to what the speakers has been mentioning, Azrul, Dr. Haris just now, Mr. Azhar, there's a lots of information that is so interesting. Okay, I think. All right, Azrul, we catch up with you later. Be prepared with the questions. I think we'll up the questions later. Thank you so much.
You're
All
welcome,
right. Okay. Okay. Dr. Haris, I might need to call you up because I think Che Azhar is having a problems with the internet. Dr. Haris, we receive a lot of questions, but let me go through the questions that's already being identified earlier. Yeah, Dr. Haris, we know that when we talk about the power generations or in the turbine being used or oil and gas, our approach with the aviation is slightly different. Yeah, but after all, during your presentation, you did mention about the digital transformation and such. Yeah, so what do you think of continuing educations of the digital transformation, which is I think is crucial at this moment? Can you elaborate more?
Okay. In terms of injecting the data science into the current education system, okay, I think that will be the questions that is being asked, right?
Yeah.
So if you look in, okay, I can explain based on what I see right now. Most of my teams, because I have a complete team, consists of data analysts plus rotator experts or rotating engineers. We need a combination of both, right? Because in order to monitor any equipment, you cannot rely simply on the technical know-how. You need someone to also have a depth knowledge in terms of the data science itself. So how to inject this is basically maybe, okay, maybe on the education system, education sector, you can look back into your modules, try to introduce new things. The things as a basic, for example, you can start to look into simple software that can assist, that can become a simple tools that can analyze things. I can quote a few examples, like even myself, I start to encourage my team to start to utilize Power BI, right? I think if you look into resumes of new students who just graduated, they will always mention about, oh, I'm very good in utilizing Excel, PowerPoint, Words. Okay, those are considered basic. But for me, if I were looking into the new young graduates, they just graduated from university. Now I'm looking into those who has at least knowledge or know-how in terms of utilizing Power BI. Power BI is just an extension. Whereas it's just another software, also under Microsoft. Okay, you can always buy as part of the Office package. Okay, if you have someone who knows how to do this, at least it gives you an added advantage in terms of it's like a selling point. Okay, for each individual. It means as a potential employer, they know, oh, this person has an advantage because they know how to utilize tools that can assist in terms of data analytics. This is just one example. Okay, but again, maybe nowadays we talk about engineering courses. We concentrate more on the engineering requirement. Why? Because I don't blame the university, because more or less they are binded by certain rules and regulation. Okay, we have Washington Accord, and then we have can't remember. Is it Sydney Accord, the one that MIAT is currently following for the technologies? So you
Yeah.
need to meet certain minimum requirement in terms of the technical requirement. So maybe, okay, in the future you can expand by offering the students some additional courses. It might be elective, it might be compulsory. It depends on the whole duration of each semester. But I believe that it is good if you can expose the student during your university year in terms of basic knowledge in terms of data analytics. Okay. There's a lot of courses actually being offered outside, but those for me is considered quite expensive. If you can train the students starting beginning during the university year by providing some real case example, I think the best way to use also use case is actually you just utilize the data of our COVID-19 cases. From there, actually, if you have the data, actually, I think you can just download the data from our Ministry of Health. I think it is just mentioned. You punch in the data, can you punch in the data into Power BI, and you can generate a lot of analytics from that. Okay? You can predict, okay, you can come out with your R naught, things like that. So those are the things that you can always explore. So try to play around with the data. Okay. So worst come to worst, if the university does not offer any data analytics courses for some reason, okay, maybe because it requires some investment, like that. I think the student nowadays, they are much more creative. They can always refer to YouTube. There's a lot of free channels that provide free, at least introductory course on how to utilize this software. Okay, Dr. Azia, I hope I have covered that questions.
Yeah. Thank you so much. And actually, we're receiving a lots of questions, but I'm not be able to portray it here. But it's okay. Thank you so much, Dr. Haris. And I think being the 17 years in the industries, I think it's seeing the whole things, the transition between those early days and if you may answer this, I think the COVID-19 pandemic is creating, and I can say that it's make things faster than it's supposed to be. Did you kind of like agree with me?
Yes and no. Okay, because currently I think the advantage, at least for me, because I've already been on the fields. So if I were to work in office or in even at my home, I don't feel it as an issue. I'm just afraid for the next generation to come because you will see a big gap in between. It's like a generation gap because for those who just about to join the industry, right, most very unlikely they will get the same chance that the previous generations has gone through, meaning that they will be a lesser exposure in terms of going to the site. They might be only able to see the equipment just from the screen. They have to rely much upon on data or even on videos, things like that. They might not be able to see the equipment physically. So now we might be able, still be able to survive based on the people that we have, but sooner or later, the people that we have right now, like myself, like my colleagues, we're going to retire in maybe 10 or 20 years. You will see a big gap in terms of the generation. That especially for the graduates who graduate during this COVID-19 pandemic. Okay, then I think the problem will be seen in the industry where you will see a big gap there.
All right. I think I will add Azrul also online in here. Yeah. Uh, okay. Thank you, Dr. Harris. Might be we catch up together, yeah, in this platform together with the panelists. Azrul, there's a questions from Zil Kamal. Yeah, Mr. Zil Kamal. Thank you. He was asking about the DICA and approved CAM release document.
All right, so first of all, hi, Mr. Zil. Mr. Zil Kamal is a very well-known guy in GE lah. so I
Yes,
felt
he's
like
a very
so
yep.
I felt like this one is like a pop quiz question to me. All right,
Okay.
so to answer those questions, so is DICA an approved CAM or DCA release document? The short answer is yes. All right. The long answer is because so DICA is approved under EASA and FAA Part 21 Subpart J under the DOA approval. All right. So hence DCA is recognizing or they approve this DICA lah. But those operator, all right, the customer, the airliner, they have to approve the DICA first, right? And to approve that, to approve the DICA before they use the DICA, to approve that, they must have their DOA approval as well, right? Some our airline customer they do not have the DOA approval, so they have to go back to their local authority, right? Their NAA, National Authority Agency, to national so they have to go back to the local authority to get it approved because they don't have the approval themselves, right? But in short, yes, it's approved by DICA. It's approved by DCA. Sorry.
Okay, there's a lots of questions. I need to find the most appropriate one. Okay, Dr. Harris, there is a questions from wait, Surya Faisal. I'm not sure whether okay. She was asking about does the aforementioned overhaul, I'm not exactly get the correct words, yeah, overhauls a work frame apply similar to the industrial gas turbine, and if you might want to answer that.
Do you want me to answer or Azrul
Yeah,
to answer?
because I think it's something that this is something that is when Azrul was presenting, and I think
Yeah.
might be both
Yeah.
of you can answer that. Yeah.
Okay. Let me start first. Okay, Azrul. Right.
Yeah, sure.
Actually, in a nutshell, you talk about the engine itself. Okay, more or less, the process might look the same. You talk about inspection and so on, but the detailing part, okay, because the usage might look a little bit different. Okay, the way they calculate the running hours, where you utilize under industrial versus aviation, might have a different approach. Let's say, for example, if you utilize for oil and gas, and suddenly we have to run under harsh condition or even under utilizing liquid fuel for certain condition. Actually, when you start to introduce liquid fuel such as diesel or even jet A1, actually, in other words, you are penalizing the running hours of the units. So you have to put some multiplication. So you are shortening the life of the machine. So you have to embed that additional running hours into the running hours of the of the unit. Okay, so we talk about the overhaul itself. Okay, it depends on each machines by an OEM. But if you talk about aeroderivative, they have certain running hours, and again, it depends on certain models. Okay, it depend. And we talk about oil and gas, definitely we want to have a very fast exchange mode. Why? Because number one, they always focus on the production itself. No production meaning no business for the oil and gas. Because our main business is more on producing the oil and gas itself rather than maintaining the machines. But there will be cases where, okay, people the management might be deciding, okay, let's run the machine under extended hours because we know after 7 days we might be able to cover the cost of repairing the machine. I'm just giving you an example. I'm not saying that my company does that, but there might be certain cases where it implies in that condition. Why? Because it depends again on the business objective. Okay, we are not in the business of handling gas turbine, but we are in the business of generating. Our main product will be oil and gas. So I'm coming more from that particular angle. Does that answer
Or
your question, Sophia?
I hope so. I hope so. Okay. Can we
Azrul?
move into the next questions? To Azrul. Yeah, we have another questions. Okay, from Nur Shahira. She was asking about what is the major processing system have you implemented in the last few years? I think the questions might
Ah,
be too generals, but if you can answer it briefly.
yeah, okay, Ken. So we do have implement some few new processing system lah. But the one that I can remember is the one that I'm very fond of is one of the what we call the TGB or the transfer gearbox, radial drive shaft. There's one component of the gearbox lah. All right, so there's one new inspection process required. I mean, is to measure the thickness of the shaft. So before that, because it being a new process, not all GE shop. I mean, at the time, all GE shop doesn't have that process, right? When they introduce that requirement, so we send those part to outside to other GE shop and to the third party shop as well because they don't have that capability. So we have and we end up with being to scrap the part lah. The part being scrapped lah. It's around $25,000 a part. All right, so we keep scrapping those parts. I think around 10 engines we scrapped. 10 shaft were scrapped from 10 engine. All right, so, and then we decided to bring those the capability in. So we buy the right equipment, we train the personnel whatsoever. We come up with all the process control, and with that, because we have those process in house, now we managed to salvage the last 10 shaft that we scrapped. Um, so we managed to salvage to regain to cover the cost about two because 10 parts is about $250,000, but our our cost to implement the project is around $2,000 only. So we were recognized by the GE CFO, the Chief Finance Officer. We were being awarded for that project lah.
All right. Okay. Thank you so much, Nushahira, for the questions, and thank you, Azrul, for answering that. We received lots of comments in here. Yeah. Okay. Miss Surya Faisal said that yes. Thank you, IR Dr. Haris. Very interesting insight. Yeah. And Shahira said, okay. Thank you, Azrul. Okay, seems like we still lose Mr. Azhar. Yeah, there's some technical difficulties on his side, but yeah, we have another questions. But I think this is from different platform. We have a question from YouTube just now, yeah, from Shahira, and we have from Facebook, different platform. Okay, there is a questions from the audience to Dr. Haris. Dr. Haris, he was asking, let me check back. Okay, yeah, he was asking about being being in Petronas is something that all the students dream about. You know, like they was asking a simple questions. Actually, they was asking about is there any possibilities of UniKL MIAT student to be part of the intern program at Petronas? Is it possible, Dr. Haris?
The answer is yes, because I believe Dr. Azria knows that I've already undertake a few interns from MIAT itself for the past few years, right? So the advantage that I see is why I took MIAT student, first of all, because you're already seen, you're already exposed to gas turbine, right? If you can see that from Mr. Azhar's slides earlier, we talk about all the machines, you have seen it physically. So it will be an advantage for me to take this to the intern. Okay. And number two will be the duration itself, because the duration that's been offered by MIAT is actually 6 months. So the longer duration is better for the company, because we don't need to retrain new interns, because there are some universities, in fact, if I talk about my own alma mater, UTM, they are still holding into the traditional 2 to 3 months of internship period. Okay, so it's not that I'm not supporting my own university, but I foresee that it's better for business point of view to undertake people who at least have longer than between 5 or 6 months. Is just something very preferable by the businesses.
All right. I think for those who's asking, there's a few questions related to the interns, and I think yes, I also know some of the students that currently working with the Petronas after they finish the interns, and Dr. Harris was saying that 6 months is a very ample time for the students to learn, and then based on their performance, they can look for opportunity to work with the Petronas. Thank you, Dr. Harris. And yes, Cik Azhar is back with us. Cik Azhar, we got a questions for you. Waiting online.
Okay.
Yeah. Okay, Cik Azhar, there's some people was asking that we have degree in mechanicals and we have degree in avionics. Does MIAT going to have a new degree program for turbine engine? Can you share with us a bit of the insight?
Yes. Okay, just hang on, yeah.
Maybe just share a bit of the informations on the what is the name of the program, for examples, and what we're going to do with the new programs.
All right. Can you see the slide now?
I think we kind of like run out of the time. We might not be able to show the slide, Cik Azhar. Maybe you can go through of the slide.
Okay. Basically, the program is a specialized course. We call it a Bachelor of Mechanical Engineering Technology in Gas Turbine with honors. Yeah. So basically, this course, our vision for this one is to provide a hands-on specialist course to provide knowledge and the skill to meet the real world needs of the global aviation, oil and gas, and power generation industry. So it is slightly different. It's much we have currently with the Bachelor of Mechanical and also in avionics. Currently we have in UniKL MIAT. Study is more on the mechanical end of it, which is one step ahead, where we will not only maintain the aircraft and engine, but we also have maintenance operation for all the three sectors, for the oil and gas, for the aviation, and also for the power generation. And on top of it, because it's designed for mechanical trade, so the graduates are more towards the development side of it, yeah. So they can go into operation and maintenance. They can also go into the maintenance. And the subjects that we provide basically is so we have 72% of the mechanical branch subject with basically we have the thermodynamics, we have fluid mechanics, applied engineering mechanics, mechanics of material, calculus, turbo machinery, electrical electronics. So those are the fundamentals for mechanical engineering course. And the specialized one is where we go to the third year, where we go into things like aviation gas turbine, industrial gas turbine, and power generation. So we have subjects on aviation gas turbine, industrial gas turbine, performance and testing, one of them, engine health monitoring, which Dr. Haris mentioned earlier, that with this program, we are able to cater for the three trades, the three areas of gas turbine. Yeah. And this will be more towards the, we have the opportunity to go to these three areas. Yeah. Yes, it's a 4-year course, 18 weeks per semester, 8 semester, and it's Education Council. Yeah. Apart from a full-time course, 4 years, we also provide a flexi learn, which takes you up to 5 years. Yeah. So yes.
Okay, I think that will already give us an insight that when we talk about the gas turbine engine from the oil and gas point of view, and also from Azrul from the aviation's gas turbine engine, I think Cik Azhar, we can't wait to see more detailing on the program that cater all these three major parts. Yeah. If I may ask you a quick question, Cik Azhar,
Yeah.
when do you think that this course will be available at UniKL MIAT?
Okay, it's expected to be launched in 2022 in September. Yeah, it's about a year from now. So we are in the final stages, just waiting for the approval from the process. So that will take a year from today, and we hope everything will go fine. Yeah, according to that. Yeah.
All right. Thank you so much, Cik Azhar. To all the panels, we actually already 9 minutes past 4. Yeah. So I think it's still okay because we're still receiving the questions. Is it okay for the panel to still? Okay, perfect. All right.
Yeah.
Okay. All right. Thank you. Okay, Cik Azhar, we got a question from Mr. Zil Kamal again, asking
All right.
about questions related to our campus in Subang. Okay.
Okay.
I show you the questions. Okay. Question for MIAT. Any firm timeline when the access taxiway to new MIAT hangar in Subang? I know that Mr. Zil was asking this, and Azrul was mentioning that Mr. Zil is from GE himself, right? Previously. So GE and UniKL MIAT Subang is just a neighbor, but we are being separated by by a fan in front of us, so that we cannot go directly to the Malaysia Airlines hangar. So, Mr. Azhar, can you give us a roughly answer? This question might be sensitive, but any insight?
At this moment, I don't have information on that. Yeah, it's quite difficult. It's quite secretive, actually. Probably we should be able. They are working on it, actually. Yeah. So I don't have a timeline, to be honest with you. Yeah, Mr. Zil. But we have been working this for years. Yeah, and we hope things will materialize. Yeah.
All right, thank you so much. But yeah, he might not be able to answer exactly the timeline. But yes, as we are concerned also in UniKL MIAT, we are work very closely with the authority, with the locals, authority, Selangor State and such, in order to make sure that this taxiway can be realized. Yeah, as currently we only have. Helicopter running from our side, three different companies, yeah, that running. If we have our taxiway, inshallah, there will be a lots of things can be carried out at our hangar. Yep, as my virtual background at the back there, yeah, the hangar in Subang.
Okay.
Okay, I have a question for Azrul. Okay, there's a lots of questions, but I need to choose wisely. Okay. All right, Azrul. You are an alumni. Okay,
Yeah.
this is from separate questions. I cannot show it in on the screen. You are an alumni. You are graduated in 2011, and you
Yes.
are embarking not directly to the GE in the first place. You've been through lots of different fields. All right,
Yes.
like SME, you were talking about strength. All right,
Yes.
so there's a questions asking about what made you choose GE, because when we talk about GE, their only specializations is in the engine. But if you go for strength, your scope is wider, designing a lots of different things. All right. So maybe you can
Yes. Yes.
answer that. Yep.
Yeah.
Yep.
Sure.
Thank you.
So this I would say this question is quite personal lah. Okay, so it's the reason is because I'm always a big fan of of mechanical, especially on engine, right? Even during my school time, I always look up study on piston engine. Is the I mean the passion came from, I think it's typical lah. The passion came from normal for boys that we love cars, right? We love automotive, we love cars. When we were small, we were talking about like modifying engines or whatsoever. I mean, all these talks. So we were like, we fell in love with engine or power plant. So my first love was the piston engine, right? Um, I during that time, aviation was not in the picture lah. Aviation was not in the picture. So, but when before I did my degree, so I went to MIAT to do. There's an open day in MIAT. All right. So there's one the white Cessna aircraft. I think the Cessna 152 or can't remember. All right. So I saw the engine. It looks like a car engine. It looks like an automotive engine. So I started to ask questions from the student there. So they said yes, it's a piston engine. So from there I know, okay, I want to go to MIAT. All right. But even that time also, there's aviation is still not in the picture. I just want to work on the engine, right? Okay, and then further on, I start to fall in love with aviation lah, basically. And then from piston engine it transitioned to power plant, right? But when I graduated, I have I have to start my career at other company first, right? So to build up my experience first, just waiting for the right opportunity. So after 6 years working on other field, on other company, then I got the opportunity to join GE lah.
All right. Okay. Thank you so much, Azrul, for that answer. Yes, I know boys always love cars, and especially when they are so fast. Yeah. Okay. Uh, Zaha. Okay, Dr. Haris. Actually, there's a questions about the people know you, IEM. Yeah, a question also from the Facebook on my personal page. He was mentioning about the IM, because in those early days, your poster came up to my post at Facebook, and then you are representing the IEM. All right, maybe you can tell about the a little bit about the IEM.
Okay.
All right.
IEM is the Brunei Institution of Engineers. Actually, our as a layman, I will see IEM as a NGO. Okay, it's different from PEM. PEM stands for Board of Engineers. Okay, it is part of like a government body which regulates. They came out with all the regulations. Okay, they come out with the act, the engineering act. So when it comes to governance, yes, it's under BM. But for those who are interested to get involved with the society or returning back, similar like what I did today, okay, give talks or try to be create your new network. So you can always join IEM. So in IEM, they have a lot of sub-technical division. Okay, how they divide the technical division is actually based more or less based towards their own disciplines. They have technical divisions specific on mechanical, technical division on electrical. I think in total they have about 17 numbers, or sorry, 18, I think, 18 numbers of technical division to serve specific interests of either disciplines or sometimes even industries. In my case, I'm currently active in two of them. The first one being a mechanical engineering technical division, because I'm graduate on the mechanical degree. And number two is actually I'm also active in project management. They are also actually oil and gas technical division. But why I did not active in that, because I believe that I already met more or less the same people during my work time when it comes to oil and gas. So when I joined IEM or being active in IEM, it's more like to create new network. I would like to know how other industries does it. So this is where I can leverage my knowledge by joining IEM and expand my network, know other people from other industries. So those are the advantage. But bear in mind, when you try to be active, it means you have to work. Usually, I need to spend my time on IEM activities beyond my normal working hours. Okay, so those
Yep.
I need to give early warning. So it means you have to spend your
Yeah.
personal time in order to be busy with those societies.
Yes, thank you so much, Dr. Haris. Actually, that questions lead to Sam Haziq question to Cik Azhar. Yeah, is any of degree program in MIAT accredited by BEM? So I think we also already answer the questions. Yeah, we are accredited by ETEC. So Cik Azhar, maybe you can brief a bit about the ETEC. You're muted. Okay.
Okay. All right
Yep.
now. Okay, ETEC is basically a governing body that will accredit or monitors and control all the programs which is under engineering technologies. Yeah. So in engineering technologies, in other words, basically we are the applied engineers. In other words, engineering technologists are applied engineers. Yeah. So they don't do actually more on design and but more on the application of the knowledge that they learn at college, at university, and so on. But towards the end, yeah, they can be professional engineers. They can go for the professional engineers like the IEM and so on. But there is a career path to that. Yeah. But basically, to answer your question, yes, we are not accredited program. Yeah.
All right. Thank you, Cik Azhar. I think we are almost towards the end. But before we end up the session, yeah, the titles of our topic for today is a gas turbine engine. Is it worth exploring? So we would like to know the questions and answer by the panelists. Yeah. Maybe we can start with Dr. Haris first. Gas turbine engine worth exploring? Yes or no, and why? In your
Okay.
point of view.
I think I've covered this in my slides. I've shared with the crowd on why actually to justify myself in terms of why it is worth exploring, because there's a lot of opportunities when it comes to gas turbine. It's not only about working with the big brands like GE, Siemens, Airbus. It's actually there's a lot of other supporting system, or in fact you can also join on the operator side or even on the R&D on the suppliers. So sometimes being a student myself, okay, I've been a student 18 years ago. I think I was lacking in terms of those exposures. I wish I can know earlier, okay, during my students, I need to be aware of what kind of engineering house or companies which actually contributes or involved in gas turbine so that I can plan earlier. So this is where, I mean, MIAT, I think they can play their roles by start to introduce to the students at a very young, very, very early stage, okay, to expose to them, to tell, okay, it's not really about all those big brands. There's a lot of other opportunities, okay, which actually, if the student knows how to tap into the market, and actually they can utilize their knowledge in terms of gas turbine and apply it in their career. Okay, Dr. Azia?
All right. Thank you for your answer, Dr. Harris. And to Cik Azhar. All right. Gas turbine engine. Is it worth exploring? Might be you can give us a last input for this session. Yes. No.
Can I share the slide, please?
Yes. Yes. Did you already? Okay. Wait.
Okay.
All right. Oh, you prepared. Okay. Okay.
You can see now? Yeah?
Yes. Yep.
Okay, basically, yeah, gas turbine, it's one of the opportunities to support government initiative. Yeah, I think it's a very sophisticated piece of machine and engine. I think we all know there's a lot of improvement and a lot of opportunity in terms of developing a nation status. Yeah, and then the middle class, increase the middle class society, increase high income society. So those are the opportunities I think we will find in aviation, in oil and gas, and also power generation. Yeah, not saying that the other professions are lower, but these are the. There is a growing trend in the gas turbine market for aviation power generation. As you can see from here, this is from the Prof and Sullivan, right? In terms of this gas turbine, in terms of 14.6 billion US dollar was in 2014, and they project to it's 23.65. Of course, now with the pandemic, okay, there's a slowdown in this year. 2021, there will be a slowdown, probably about 30% or 40% slowdown. And a lot of airlines have cancelled their orders and so on. But as far as aviation, as far as power generation, the growth will be there. It's a matter of cyclic effect. Yeah. So I see no reason that we should not explore in this trade. Yeah. And similarly, on the aircraft, this for the aviation, there's a rise. There is a steady rise. Yeah, 3.9%. Drop, probably this will drop lower, yeah, but there's a time where it will pick up. Yeah, I think probably 3 to 5 years from today, you will see this will be moving up. Yeah. Thirdly, aviation. Yeah, the aviation has always been started from the beginning. It's established so long. And the gas turbine is finding it's increasing application on power generation, oil and gas, chemical process, and so on. Yeah, so there will be a growth. Yeah, no way we can deny that. And finally, of course, for any equipment or any product, research and development is a must actually. Yeah. So I see gas turbines have proven a reliable piece of equipment that still have important technological economic growth potential. You're talking about power generation, a single cycle, 40% with a combined cycle. So there's always been a potential in the development of gas turbine. Yeah. And that's it. I think we should not back off. I think Malaysia should seriously focus in these areas. I think we are more on the maintenance and operation. I think we should go more towards on the development of this equipment. All right. Thank you very much.
All right. Okay, Azhar, thank you so much for the sharing on the your insight. Okay, then Azrul, over to
Yes.
you. Gas turbine engine, is it worth exploring from your point of view?
Yes. So I try to make this quick from my point of view, the short answer is yes. It's worth exploring to GTE because what I think is GTE will be here for a long time. All right, so it's unlike the automotive industry where the talk is now they are talking about EV or electric vehicles, or even some kind of manufacturers they're vouching that they will be stopped producing piston engine or internal combustion engine by 2030 or 2040, right? So unlike automotive, so gas turbine engine will be here lah for a long time, all right? And on business wise as well, I mean, some of my friends were asking, is aircraft is still flying because this COVID time, because people are not traveling, they were asking, are aircraft still flying? Do you guys have business? How's your business work right now? So we do have aircraft flying, all right, especially on the big country like on the USA or China. So they are still domestic flight that are flying, right? So all those engines need servicing and overhaul, right? So business is still there, right? And then I think this is just assumption lah. I mean, all of us were eager to go to travel, right? We are just waiting for the band to be lit up, and then all of us want to travel. So it will be there. So gas turbine engine will be there lah, right? So it's worth exploring, and your future will secure, inshallah.
Inshallah. All right. Thank you so much to all the panelists. But before that, I would like to put the comments that we have from we start. Yeah, might be we not be able to comment it now. Okay, I'll show from Mr. Ramasani Karnans. Actually, he's our staff in UniKL MIAT, working in the hangar and working with the engines, asking about how everyone. Okay, we are good, Mr. Kanan. And then we have Samil Shari. Hello and salam, Shamil TFA Aero from GE Philco Aero Oil and Gas. Shamil is also our alumni. And you can see the profile picture is UniKL is also where Jodo is applied. Met his wife at UniKL MIAT and got married. Okay, and then we have from YouTube, Woman in Aviation's MIAT, Samil was saying that, Samil will say hi and hello. Okay, and then we have Izzuddin Daniels, our alumni. Hi everyone, Izzuddin is here. And Mr. Rahmat, Dr. Rahmat, Chazi. Hey, Mama Azrul, say that cool. Right, and then we have Akila Sofina, Cheryl Fahmi. Might be some of the panelists know them, yeah, because they come up from different, might be from Petronas, might be from MIAT or alumni. And then Hazni Abdul Hamid, say hi. And then Donut, I think. Actually, Irwan. Hi, Irwan. I hope you're getting better. Irwan's supposed to be our panelist, but due to some health concern, he not be able to join us in next time, inshallah. And Azrul replacing Irwan. So, Irwan, thank you for watching and thank you for being with us. And Aida Rohana. Okay, Aida Rohana is the regional director for Hadid, working in the aviation field, company based in Dubai. Thank you for watching. And yes, as usual, Mr. Zil Kamal is always be there with us supporting, during Azrul presentation. And then we have, I think Azrul also kenal. Mr. Shahidi used to be the ex-GE manager in, I can't remember in which department. And now
Training
he's
department.
training department. And now he's with us, all right? He's also an alumni. Now he's a staff of UniKL MIAT. And Shahira was saying that thumbs up. And then Khairul Anwar was saying, thanks a lot, UniKL MIAT, for hosting this a very informative session. Great local panelists. Yes, we have Dr. Haris, Mr. Azhar, and also Azrul here. Thank you, Khairul Anwar, for watching. And then let's see, Zil Kamal again, great works. And then Shahira, thank you, Mr. Azrul, for answering the question just now. Again, Mr. Zil Kamal, thanks all for panelists. And Aisha Hani, great sessions. All right, okay. I think thank you so much for all the audience. I just be able to watch only from one side. We can see 29 viewers, but from different view, I can see from my personal, I have 59 viewers. I think in one shot we have more than 100 participants, and I hope that we creating a best platform for those interested in the gas turbine engine. Again, Dr. Haris, thank you so much for being with us and sharing the information on the oil and gas perspective. Azrul's our own alumni sharing in the perspective of the turbine engine for the aviations from GE. Thank you so much for your time. And our own Mr. Azhar, our specialist. Thank you again. Thank you so much for being with us. Thank you again for the panelists, and I hope to see you again. Inshallah. Thank you again. So I will put the our panelists at the backstage. I hope they can stay so we can take selfie after this. But before I go to the audience out there, we would like to share with you about this one. Yeah. Okay. Let me. All right, our master and PhD by research, area of specializations in aerospace. Perhaps the insight of the gas turbine engine just now can give you an insight of the topic that you would like to explore. Yeah? Dr. Haris was giving lots of information about the oil and gas, about the future research, digitalizations informations, about the environments, yeah, and a lots more. And Mr. Azhar was giving an inputs about our new degree programs, and also Azrul also was giving an insight about the aviations related, yeah. So we have a postgraduate, master in aerospace, and also PhD in aerospace. So we hope that you can go to the website of UniKL for more details. All right, so I think with that, again, thank you so much for all those audience that watching. I think I will hand it over back to Dr. Zul.
Thank you, Dr. Azaria.
Dr. Zul.
Thank you for the session.
Over to you, Dr. Zul.
Okay, thank you. Tuan-tuan dan puan-puan, berakhirlah kita punya session pada hari ini. Let me show you again. Okay, so we already have unmanned aerial vehicle talk, and today we have the gas turbine talk. Hopefully in next 2 to 3 weeks we have another session, this time with advanced composite technology. As you said, Professor Dr. Khairul Dahari will have the session talking about the advance in the composite technology, especially used in aerospace sector. So sekian saja. Terima kasih kepada yang bersama-sama kami selama lebih kurang 2 jam ya. So jumpa lagi dan Assalamualaikum.